Hi, I'm Mr. Huber, and in this video we're going to solve exercise 3. Sketch the graphs of the functions f of x is sine of x and g of x is 2/3 into one system of coordinates and work out all the points of intersection. Well, look, this is my x-axis, this is my y-axis, and my sine is always between 1 and -1. That's why I have drawn these lines already. Now, my sine is like this. This would be pi, 2 pi, 3 pi, 4 pi, minus pi, minus 2 pi. So my sine function would look like this. It starts at 0, 1, a nice and rounded curve like this. Here we go. I'm drawing more than one period length. I have 2 periods over here and 1 period on the left hand side. Nice and rounded shape. Won't be perfect, it's just a hand sketch. That's all we need, a hand sketch. And now this is my function f of x is equal to sine of x. And now 2/3, that's 0.66. Around about here. Okay, let's draw this horizontal line here. And you can again see that we're expecting infinitely many points of intersection. Here, 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 and here. And if we were able to continue the line, it would have many more. And g of x is 2/3. Now look, we need a calculator for this because we need to set these two equal to each other. And sine of x is equal to 2/3. We don't have this value memorized, so we need a calculator for this. So it's x is arc sine, the inverse sine of 2/3. Make sure that your calculator is set to the radian measure. Okay, so let's do that. Shift, here we go. Shift radian measure and arc sine 2 divided by 3. That's 0.73 approximately. X is 0.73 approximately. Now look at this. We can look at it in a unit circle. So this would be our unit circle. 1, 1. So this is about 2/3. Here, 2/3. So it would be up here. Okay. So now this is 0.73 approximately, this part here. But we know the sine has another value like this. Look, this is 2/3. This is our sine value. And we do have another one over here. It's symmetric with respect to the y-axis. And this part here is obviously pi minus 0.73. So let's work that out. Pi minus the previous value. So that's 2.41 approximately. So we have x is approximately equal to 2.41. This is plus k times 2 pi, and here plus k times 2 pi. Don't forget, this here is pi minus 0.73, as you can see on the unit circle, because this part here is 0.73. So you just subtract this part from pi, half a circle. So you do have these two solutions. So do these two solutions make sense? Yes, they do. Look, 0.73, that's approximately here, 0.73. And the 2.41, that's here, 2.41. So let's highlight this one in red and this one in with a pencil. Now, as you add one period length, you jump from this to this one or to this one if you subtract one. If you go for the red ones, well then if you subtract one period length, you're here now, and if you add one, you're here. You see? These are the red ones. So now we have all the points of intersections. Now look, every point of intersection, this one is 2.41 and 2/3. This one is 0.73 and 2/3, because the y value is always 2/3. All these points do have 2/3. This one would be 0.73 plus 2 pi, well, you could work it out, and 2/3. This one would be 2.41 plus 2 pi and 2/3. This one would be 2.41 minus 2 pi and 2/3. And this one would be 0.73 minus 2 pi plus and 2/3, not a plus, and 2/3. These are all the points of intersection. Now look, this would be a more exact drawing, but it would be the same thing. You see, I could go through 2/3 here, that would be around here, and you can clearly see that it checks out. This is pi halves, so this is 1.5, and this can easily be 0.73. If this is 1.5, then this matches the 0.73 approximately, and this could easily be the 2.41. So it's more than okay, even with my drawing. Although my drawing is not as perfect as this one, it's all I need. And you can see, you can interpret your solutions on a unit circle. Well, either it's 0.73 plus full turns or minus full turns, and you're always here. Or it's 2.41 plus or minus full turns, and you're again here. So the interpretation as the graph of the sine function intersects the horizontal line going through 2/3, or on the unit circle. I hope it wasn't too difficult. See you on the next one.